Hey Thinksters, and welcome to this video where I want to explain you the Python list extend method. So yeah, how can you add not one but multiple elements to a list, like 2, 3, 4 elements to a list? Actually, surprisingly, many people don't know the answer. Many people just have an append operation, so they call list.append and then append one element again and again and again until they have added a number of elements which they want to add. But actually there's a method for this which is called extend method. It's very efficient, much more efficient than multiple append methods, and yeah, you should use this method if you want to achieve this. Okay, so let's have an example. Say we have the list 1, 2, 3 and we want to add all elements, say in the second list, like 4 and 5 to this list, to the first list. Then you simply call list extend list 2, and now you can print the list and you see that the list itself changed. Okay, and there are a few subtleties which I want to address in this in the following part of the video. If this is already everything you needed to know, then you can safely skip the remainder of the video. But I will explain some important things like the return value of an extend method, how you can create a new list rather than only extending an existing list, performance issues, what is the computational complexity, and so on. So I will address all those topics in the remaining video, but as I said, if this is already everything you need, then you can skip the remainder of the video. Okay, so let's have a few like examples how you can so where I will explain some things by using the examples. Okay, so the extend method actually takes an iterable, not necessarily a list, as an argument. Okay, so therefore you can do something like this. For example, you can have range 20, for example, which means that the return value of the range function, which is a built-in Python function, it just gives us an iterable of a sequence of increasing values. Okay, so if you call this, so like maybe first give you the range 20 result, you see it's just in a range object, and a range object is an iterable by itself, so you can iterate over a range object. So what does it mean, an iterable? Yeah, so an iterable is just an object where you can do the following. You can do for I in range 20, for example. Yeah, you see range 20 is not a list or something, it's an iterable, so you can iterate over this object, and we can simply print it, for example. Okay, so you see it prints all values. Okay, so it doesn't require a list. Often it's more efficient to just provide the raw iterable. An iterable, for example, a list needs to maintain all values in the memory, in the RAM, but an iterable doesn't have to do this actually. I mean, you can, for example, you can dynamically recompute the next value based on the previous value when you define an iterable. So an iterable can be much more memory efficient, can be faster than a list. So you can, in many cases, it makes sense to just add an iterable to the list. Okay, and here we have done this. We have extended the existing list with an iterable range 20. So what is the result of this list? Yeah, it's the previous list which we have previously created plus the values in the iterable in this sequence. Okay, so this is exactly in this sequence. Okay, so then one common question is, how can we, so now you know how to append a new list to a given list, okay, at the end. But what if you want to do this somewhere in between, say at index I, or even at the beginning of the list? So for the append method, which appends only a single element, this is easy because you can just call, for example, let's create a new list, 1, 2, 3. You can call insert. Then you have to specify the index, which can be, for example, 2, and the value like 99, and you can print the list, and you see that 99 is now at position 2 in the list. But this only works for a single element. What if you want to insert a whole sublist? So then in this case you can use the for example, there are many different ways, but you can use list concatenation. So you create a new list, and you have, like, say you want to insert a whole sublist at position 2, which means that you use slicing. So you slice from the left until you reach position 2, the position where you want to insert the sublist. Then you have the new list. You use the plus operator for list concatenation, which just glues together some lists. Okay, so we glue the initial part, like the prefix of the list, at the beginning. Then we have the say our new list 42, 42, 42, and then this is the list we want to insert, and then we have the remaining list. So we slice from position 2 to the end. If you have some problems with slicing, then check out the slicing tutorial on the Finster blog. Just Google Finster slicing and you will find it. I also have written a book, Coffee Break Slicing, which is available for free for all my list subscribers. So if you subscribe below, you can also get the book for free. Okay, so now if you do this, you see that we have now inserted basically, so semantically we have inserted 3 elements here into the list. But of course we have created a new list. So each time we call the list concatenation operation, we have created a new list. So we cannot do this basically if we want to modify an existing list, then we have to iteratively call the insert function basically. This is how you would modify an existing list. Okay. Good. So then the next question is, so what is the say the performance of the extend method? And I can give you a quick example. So let's measure the time. Open a new Python shell. And I've already prepared something. So we import the time module, and now we create a new list. Okay, and we extend this list with a like 100,000 elements, for example. Yeah, so with the range function. And now we need to measure the elapsed time. So we have a start timestamp and a stop timestamp. Calling the time function. The time function gives our method gives us just the current time in seconds on the system. So therefore, if you want to know the elapsed time, then we simply need to calculate the stop minus start values. Okay, so this gives us in second the elapsed time, and we have to convert it to a string as well. Okay, so now if we execute this code, you see it takes about 0.002 seconds, so it's extremely fast. Let's compare this again against another way of like adding 100,000 elements. So we can also, instead of calling extend, we can also use append, for example. So we can have for element in range 100,000 to the following, like append this element to the list. So this would be the naive approach. So basically many people would actually, I've seen this a lot of time in real world code bases, because people, they are just not aware of the extend method, so they just do something like this. So they iterate over a large list and then they just append all the elements, like one after the other, calling the append method. So again, the previous time was 0.002 seconds. That's less than that's actually 2 milliseconds. Okay, so we have 2 milliseconds for this. So let's execute this function and compare and check it out. So here you see it's 20 milliseconds. So it's factor 10 slower to use the append method iteratively than using the extend method once. Factor 10 slower. So therefore you should really be aware of this thing. So the extend method is not only more readable and more concise, it's also factor 10 faster. Okay, so you should always, so if you want to add multiple elements, then of course use the extend method. So good, now we have addressed this. And so another problem that many people have is that the extend method, basically you have already seen this, yeah? The extend method, it modifies an existing list object. Okay, so therefore it doesn't return a new list or something. This is often assumed by people. For example, many people do the following mistake. So they create a new list like 1, 2, and then they extend this list by, say, some values 3, 4, and then they expect that now the result is stored in list in this LST variable. And then they do something like list 0, so they want to have the first element, and then you have this error, non-type object is not subscriptable. So what does it mean? Why does it happen? So basically, here you use the extend method. Basically, you call the extend method on the initial list 1, 2, and it extends the existing list 1, 2. So basically it appends both elements 3 and 4 in this order to the given list 1, 2, but then this is not returned. So the extend method doesn't return a new list, it just returns a non-object. So it modifies the object in memory, so that you have the modified object somewhere in memory, but you don't refer to it. It is not returned basically. Yeah, you have to, so if you want to do it right, you have to first create the object as you did previously, the list object, and then you refer to this object with this variable. So this variable LST now refers to this object. And now you basically simply call on this object, you call the extend method with the elements you want to add to the list. Okay, and now you have modified the object itself. The return value of the extend method is always none, no matter what you use as an iterable input. So it is always none, okay? So in this case, because it always modifies the existing list, it doesn't return a new list. So therefore, now you can do something like this. You can, for example, print the first element of this list. Okay, so this is how you overcome this common error. Good, okay, so this was basically everything I wanted to describe here. Maybe one minor thing, if you want to extend all elements, but ensure that you only have unique elements in your resulting list, then you have multiple opportunities, but you should then check out sets basically. Okay, so you can, for example, so say you have this set 1, 2, 3. This actually doesn't have to do very much with the extend method, but if you want to extend a list with new elements, but you want to ensure that those elements are not already in the list, otherwise you wouldn't add them, then you should use sets basically for this approach, because sets are much more efficient in terms of membership operations. So you can do something like this. You go over all elements, you add them to the set, and then you have the resulting set. Okay, so but the set, of course, you lose the order information. So the same so you would lose the order information basically. If you want to maintain the order, then you can of course also check. So you can have a list 1, 2. Now you have to add another list, like say with some 1 elements and 3 element, and now say you want to add all elements in the list, in the to add list, to the list LST, but only if they are not already present in the list. Then of course you can do something like this. You can use list comprehension. You can basically, no, maybe we should not use list comprehension. Maybe it's better to just iterate over all elements in to add and check whether if element in list, not in list, then we simply append this element to the list. Okay, and now you can print list and you see that it doesn't contain any duplicates. Okay, so this is the approach you should use basically if you care about the order. There's also a more efficient way of use of where you don't have to check the list itself, but you have to use a second set data structure where you check the membership. Set membership is really fast, so you can like have a second. So you have the list data structure, then you create a set which just contains the same values as the list, and then you can check membership in the analogous data structure, and you can then also append the element to both data structures. So in practice this would look like this. You have so say you have your list 1, 2, and then you have a set which is just you just convert the existing list, and then you iterate over all elements in list. No, in this into add basically the elements you want to add. And now you check if element in set, not in set. So this means that we haven't already added it to the list, and it doesn't exist in the current list. So therefore we can add it. So now we can call list append element, and we also need to update our set. So we have s.add element. Okay. So therefore now you see you have to do two add operations basically. So one for the list, one for the set, but it's more efficient for larger lists because otherwise, because here we check membership in a set, which has constant runtime. Here we check membership in a list, which has linear runtime each time we call it. Okay, so and here basically. So each time we call this, we have to go through the whole list, and if the list has 1 billion elements, then you have to do 1 billion operations in the worst case to check the membership, to check this elements not in list or element not in list. Okay, so this is how you could do this, and I think that's already enough for this video. Thanks for listening to this list video, and see you in the next video. Bye.